Hi everyone, welcome back. And in this video, we are going to fine tune a pre-trained GPT-2 model on IMDB custom dataset. So let's get started. So before that, you need to have some prerequisites, and you must know what these prerequisites are going to do and how these prerequisites are going to help us in this specific lecture. So first of all, you should have Anaconda distribution installed. That is an open source framework for using PyTorch, scikit-learn, and Anaconda distribution for running different machine learning, deep learning libraries using the Anaconda distribution. So make sure you have the installed Anaconda distribution on your computer, and you have the specific CUDA availability available on your local machine. So CUDA is basically that allows the usage of general pre-processing unit. So if you want to train your large language models or any deep learning or machine learning model, you can use the CUDA prerequisite to use this library to use your GPU. So let's get started. So first of all, we should import the PyTorch, and I already have the PyTorch version. So let's see which PyTorch version I have, and let's write pip show torch, and this will tell me that which PyTorch and torch version I am using. So currently I have the version 2.5.1, and the name of the dependency is obviously of course torch, and we will be using PyTorch in this fine-tuning lesson. And next we should use the transformer library, and make sure you have the transformer library installed. For that, you should write pip install transformers, and this will specifically install the transformer dependency on your Jupyter notebook. So I already have this dependency installed, and it is telling me that the requirement is already satisfied. Next, there are two things. One thing is that if you want to train your large language model on your CPU, you can simply this Jupyter notebook will automatically train the large language model on your CPU. And the second thing is using the CUDA version, which if you have a GPU available on your device, so then your large language model will do much quicker computations on your GPU, so which is a more adaptable and a good method to use. So I have a GPU available. So if you want to use your GPU, you have to install the conda install PyTorch dependencies, and for that you should run this command. So I already have the dependencies installed, so no need to run it again. Then next, if you want to see that do you have the CUDA GPU available in your device, then you will write import torch and then print. First you have to check the PyTorch version, that is torch dot underscore version, and this will give you the version of the PyTorch. So it is basically the torch, this torch dot underscore version dot. So I am currently using the PyTorch 2.5.1. Then if you want to see the available CUDA device, if you want to check that do you have the CUDA enabled or not, then what simply you would do is write torch.cuda is available, and if it returns true, that means you have the GPU available on your local machine, and if it returns false, then that means you don't have a GPU available on your local machine. Then if you want to count how many GPUs you have on your device, you can simply write the torch.cuda device count, and it currently I have one GPU. And also if you want to see the device name and the virtual memory of the GPU, you can simply write this torch.cuda get underscore device name, and if torch CUDA is available, else no GPU. So currently I have a GPU available on my laptop. So this is done. Now we have to install some pip install datasets, because we will be using a custom dataset from Hugging Face. So you will use this in pip install dataset, and I already have a dataset installed. So for your use case, when you are running this Jupyter notebook step by step, you have to install every dependencies in order to not to have any conflict or not to face any error. So I have the import dataset available now. Now let's install the pip install evaluate, which we will use to evaluate our fine-tuned model in the end. So let's run this now. So I already have the evaluate available again. So now if I want to see the installed dataset, what I will do is pip show dataset, and it will show me the version and the name of the dataset. So we will be using the open source Hugging Face community open source library of dataset. Now we will use this dataset from datasets import load underscore dataset. So basically this load underscore dataset is going to help us in loading and bringing a specific dataset from Hugging Face. So let's use a dataset. We will initialize a variable dataset and use the load underscore dataset of open source IMDB dataset. Now let's see what the dataset looks like and what content do we have in the dataset. So it might take some time because it's importing the dataset from the Hugging Face community cloud. So once it's done, it will take some time. Let's use the transformer library to import the GPT tokenizer, GPT sequence classification, trainer, and some training arguments which we will going to use to train our GPT fine-tuned version. So the dataset has been imported. Let's see how the dataset looks like. So the dataset consists of three things. One is the training, second is the testing, and the third one that it tells us that this method dataset was used as an unsupervised dataset. So we have imported the dataset successfully. Now let's copy one more command and paste it over here and to see what we are going to use. So we will be importing the GPT-2 tokenizer for tokenizing our dataset text into number of tokens into numerical representation. Then we will be using our model that is going to be the GPT-2 for sequence classification, the trainer class for training our GPT fine-tuned version, and the training arguments which we are going to pass. So let's run this, and now this is loading some dependencies of the transformers, GPT-2 and GPT-2 sequence classification. So when it's done, we will then see the dataset into more detail, how the dataset looks like. So let's see what the dataset consists of. So let's print dataset, and then we will select the training part and the corresponding information which will be set at 0 position. So this will give us the dataset of the specific area. So now the dataset consists of a set of movies which includes different kinds of movies that includes genre of actions, horror, and comedy. So let's have the test dataset to see how the test dataset looks like. And our test dataset looks like just similar to training dataset, but it is categorized into a testing dataset. So once the fine tuning is done, we will test our fine-tuned version on the test dataset. So now we need to import the tokenizer. So basically we need to import tokenizer, and for that we will use the from transformers import tokenizer, and this will basically import the auto tokenizer which we will be using, and it is a pre-trained tokenizer known as the OpenAI GPT-2 tokenizer. So in this tokenizer, our OpenAI GPT-2 is going to be loaded. So let's see how the tokenizer looks like. So the tokenizer has a vocabulary size of 50257, and the model maximum length is 1024. And then we have the padding side and truncation concept. So we will be understanding what padding and truncation is in more detail after writing some amount of code. So once the tokenizer is loaded, we have seen what the tokenizer looks like. Now one thing we need to know is that GPT doesn't have the pad token, so we have to initialize our own padding token. So what we will do is we will write the tokenizer dot pad underscore token, that will be is going to equals to EOS underscore token. So let's see how the tokenizer or pad token looks like. So our padding will be as the end of text, and in this end of text basically a special token is going to used that will help us to make arrays of tokens the same size for batching. Then we need to import the model and to initialize it. Let's import the model and initialize it. So now it is going to take some time, because the weights are going to be loaded in our Jupyter notebook, in our memory, in our local virtual memory, that is the Jupyter notebook. And let's see how the model looks like. So the model is a GPT-2 for sequence classification. It's a GPT-2 model, pre-trained model, and the embeddings are 50257. Then we have the dropout layer, and we have the convolution, number of convolutional neural network layers that are used here, which are 2304, and the number of convolution 1D layer that is also mentioned, and the dropout. So we won't be diving too much detail in this what the neural network convolution layers and stuff does. We will be just simply understanding some basic things. Let's use now. Again, we have to just as for the model, we have to initialize the pad token ID for the model and the EOS token ID. So once it's done, now we are going to create a tokenizer function to create tokens based on our own data set. So let's write a tokenizer function in which we will write def tokenize underscore function, and it will expect some example values. And this tokenizer function is going to return the tokenizer is going to return something that will be the example, and the example is going to be in the form of, because we are using a textual data, so that is going to be in the form of text, and also the truncation. So the truncation is going to be basically true, and next we will be using the padding, and padding is going to be the maximum length. Let's write the maximum length, and the maximum length we are going to initialize as 128. So once it's done, we will run this specific input cell, and we have successfully initialized our tokenized function seen over here. So we have run it, and now we have to tokenize our dataset. So in order to tokenize our dataset, we are going to use our tokenize function, and in that tokenize function we will pass some data, and that data is going to be our IMDB dataset. So let's rename our dataset by label and labels, and we are going to set a format for a dataset that is going to be some columns, some input IDs, and attention mask and labels. So this will help the model to better understand during the training process. Let's run this, and now our tokenized data set is now getting converted through the tokenize function, and we will see how the tokenized data set looks like. So it might going to take some time. Let's wait for it and see how our tokenized data set looks like. Now let's print it and see how the tokenized dataset looks like. So now the tokenized dataset is shown over here, that we have the text, the labels, the input IDs, and the attention mask. And for every parameter, that is the training, test, and the unsupervised dataset, we have the labels, input IDs, and the number of rows for the tokenized dataset. Now you need to see more detail of the tokenized dataset. So let's see how the tokenized dataset looks like. So our textual data is successfully converted into numerical representations of numbers. So GPT-2 is going to understand these numbers, the whole convolutional neural network, and the whole process is going to understand these tokenized tensors, and during the training process it will be helpful for the model to use these tokenized datasets. So for every fine-tuning process you must tokenize your dataset in order to do the pre-training process. So next we are going to see again how the tokens looks like, and let's print it. So these are the number of tokens. Now you can also, we have two method, one is the encoding method and the second one is the decoding method. So currently we have the tokenizer has done the encoding method, in which the numerical text is converted into the textual data is converted into numbers, numerics, and now that was the part of encoding. Now coming towards the decoding part, decoding, tokenizer can also decode. So we are going to convert the original data into a process of decoding, where we will see how the original data looks like and how the tokenized data looks like. So you can see, you can see the the decoding version of tokens as well. So if you want to see how the tokens want to convert into the decoding method, you can simply write the tokenizer.decode tokens. Now again another important concept is to basically split the data into training to use for faster, you were going to use the subset for faster training. So now our training data set looks like this, which is converted into text, labels, input IDs, and attention masks. Now similarly we are going to split the test data set as well, just like the training data set, and we can see how the test data looks like. So the training data set consists of number of rows 2000, and the test data includes number of rows 500. So it's a 70-30% rule. You can decide whether how much data you want to train and how much data you want in the testing phase. So it's always recommended to follow the 70-30 rule, 70% training data set and 30% the testing data set. Now we are going to use the training arguments for which we are going to fine tune our GPT model. So this is important to understand. We are going to write the train underscore arguments, and this training underscore training arguments method requires some parameters, that is the output directory where you want to save the fine-tuned sentiment analysis model. So I have named it as the GPT-2 fine-tuned sentiment, and it will be saved into my output directory automatically. Then we have set the learning rate 2e minus 5. So basically learning rate tells us this is a tuning parameter in machine learning in which we optimizing the controls, the step size when adjusting a model parameters or weight to minimize a loss function, essentially determining how quickly the model learns. So we have choose the learning rate as 2e + minus 5. You can set it on your own use case, but by default we have set the learning rate as 2e minus 5 to see how we are going to minimize a loss. Essentially it determines how quickly the model is going to learn and how much the prediction the model has done correctly. Then we have the train batch underscore size, and batch size is what it defines as that the whole the model has gone through the whole data set, so that is equal to one batch size. So batch size is equivalent to passing passing the whole data set in a one whole sequence. So it is easy. So it refers the number of data samples proceeded to gather in one iteration of training in the machine learning or deep learning models. That is what batch size is. Then we have the number of trained epochs. So epoch is basically where we are again a particular period of time. It is basically in computing epoch is a fixed time used as a reference to in how much the division of the time you want to give, in how much time you want the model to train that. So epoch is basically we are using only 2 steps. Number of training event is 2, then we have the weight decay, that is 0.01, and we have the save strategy and logging directory and push to hub. So every parameter has its own role. Now we will run this, and then we are going to finally train our GPT fine tune version by using the trainer uh, method, and this will basically train our GPT model. And now it is getting trained, and it might take some time. So now we have initialized this, and now yes, let's try the trainer dot train. So now if you have a GPU available, uh, the large language model GPT-2 is going to be trained on your CUDA device, and it depends upon the virtual memory of your CUDA device. And currently you can see that our GPU is being used 100% used, 94% used, and this is how our GPT fine tune model is getting trained now. So let's wait for it and see what happens after the fine tuning. So now it took almost 4 minutes and 36 seconds for 2 epoch, and our GPT pre-trained model is now being fine-tuned on our own custom IMDB dataset. So now you can see that the model logs directory can be found, and you can see over here that it is placed over here, the GPT-2 fine-tuned sentiment folder, which consists of the checkpoints. And in this checkpoint you have the model.tensors file, you have the optimizer.pt file, and then you have the complete directory of your fine-tuned version of GPT-2. Now you can also see what we have. Again, you can check this folder, and you will find out that the GPT uh, 2 model has been successfully fine-tuned on custom dataset. Now we need to evaluate our model. Now for that we will write the trainer.evaluate method, and this will start evaluating our fine-tuned model of GPT-2. So the evaluation loss was 0.59, which is quite good, and the runtime was 5.6, and the samples per second was 89, and every step per second took 44 seconds, and the epoch was 2. Now this is important. Now we need to see the before training, how the model is going to respond on some defined textual data, and after training we are going to see how our GPT-2 fine-tuned model is going to respond after training. So let's see. So before training, let's run this and see how the model per own textual data. Now we can see that the input, which is for example that includes, I generally struggle to find a single redeeming quality in this film. So the sentiment is negative, and if you want to see how the sentiment positive and negative is going to respond, then you must write a list of text and add some list of text in it and test your GPT-2 fine-tuned version. So in this way, in this whole way, you are going to understand how to make your own GPT-2 fine-tuned version, and how the PyTorch helped us, and how we can make our own fine-tuned large language model on any use case. So our use case was fine-tuning it on the IMDB dataset. Thank you very much, and I hope you guys are going to do some hands-on practice on fine-tuning GPT-2 on your own, or on your own custom dataset, or any other available dataset on Hugging Face. Thanks very much.